So to understand this, we'll go through a small mathematical analysis. I'm saying that consider a bandpass signal x of t equal to a of t into cos of 2 pi fct plus theta t. Now in this case, amplitude of the sinusoidal signal is a function of time, which will be the case if the signal is amplitude modulated, and phase is also function of time, which will be the case if signal is phase modulated. In short, we know that amplitude and phase modulated signals. Now, yes, if the signal is frequency modulated, again the phase will be function of time. So we have taken a general signal which can either represent amplitude modulated form, frequency modulated form, or phase modulated form. In either of the cases, the signal will be a bandpass signal. So this is the general representation of an analog bandpass signal. So what we have basically taken is analog band pass signal. A of t and theta t are called amplitude envelope and phase envelope. Let us go ahead. I can apply the formula of cos A plus B. A of t will remain as it is. Cos A plus B is nothing but cos A cos B. I write it as cos of theta t. I'll write theta first into cos. So cos A cos B, second will be 2 pi fct minus sin A sin B. Again we will write sin of theta t first into sin of 2 pi fct. So this is what we get when you expand. A of t will be given to both the terms. Now I will do small replacement. This whole a of t into cos theta t will be replaced with uct into cos of 2 pi fct minus a of t into sin theta t will be nothing but ust into sin of 2 pi fct. And further, this can be written as real part of xlt into e raised to j 2 pi fct. Now from where this expression comes, to understand that, let us first write down what replacements we have done. So we have firstly replaced for uct. So you can see uct is nothing but a of t cos theta t. ust is nothing but a of t sin theta t. So the suffix c corresponds to cos and s corresponds to sin, and xlt will be nothing but uct plus just. This is nothing but the xlt. So how this real part will give me the previous steps. So if I just consider xlt into e raised to j 2 pi fct, this whole thing will be nothing but xlt is uct plus just, and this will be multiplied by e raised to j 2 pi fct. So this further gives me, and this e raised to j 2 pi fct will be nothing but cos 2 pi fct plus j sin 2 pi fct. So if I now multiply and just take the real part, because I want real part here, uct into cos 2 pi fct will be the first term, and to get another real part I'll have to multiply just with j sin t. J into j is j square, which will be minus ust into sin of 2 pi fct, and the remaining two terms will have j in it. First term will be j of ust multiplied with cos of 2 pi fct, and the second term will have j sin multiplied with uct. So I'll just write uct into sin of 2 pi fct. So if you now take the real part of this whole thing, which is what we have used, if I just consider real part of xlt e raised to j 2 pi fct, what is the real part? The real part will simply be equal to this first two terms. So this first two terms will be the real part, and this is what we had here. We had uc cos minus us sin. So we have replaced that with real part of xl e raised to j 2 pi fct, and these are the three important signals that we have defined. So now the question is, what is this xl? So what we achieve by doing this? we simply achieve the representation of x of t, which was originally a bandpass signal. We have represented x of t in the form of XLT. Now what will be this XLT? XLT will be nothing but it is a combination of UC and US, and UC and US both are low pass signals. You can see in UC as well as US there is no FC term. FC was the high frequency, the center frequency of the band pass signal. There is no FC anywhere here. So UC and US are low pass signals, and because they together define XLT, we conclude that XLT is nothing but it is called complex low pass representation of x of t. Complex because it is complex in nature. What is more important to us is it represents low pass representation of x of t.